Hey guys, Professor Calculus is here, and today in this video we're gonna see how we should solve this integral that is really scary and interesting. But before that, make sure to like and subscribe, as it is free and you can always change your mind later. So, before doing anything, I'm gonna write the Maclaurin series for e to the x. So series for e to the x is the infinite sum from 0 to infinity of x to the n over n factorial. And therefore, I can use this series here, and my integral is going to be here. Sorry, forgot to. First, let's plug in the square root of cosine x here. E to the square root of cosine x is the infinite sum from 0 to infinity of square root of cosine x to the n over n factorial. And e to the root cosine x is the infinite sum from 0 to infinity of cosine x to the n over 2 n factorial. Now I can substitute it in here. I can say it's the integral from 0 to pi over 2, the infinite sum from 0 to infinity of cosine x to the n over 2 over n factorial. And I equals the infinite sum from 0 to infinity of 1 over n factorial, the integral from 0 to pi over 2 of cosine of x to the n over 2 dx. Now, we cannot proceed any further than here unless we use the beta function, which is defined as an integral of a trigonometric function. It is defined as 2 multiplied by the integral from 0 to pi over 2, notice that bounds do match here, of sine theta to the power of 2x minus 1, cosine theta to the power of 2y minus 1, d theta. Notice that how the powers, we can match the powers here and obtain cosine x here since our boundaries are the same. So I'm going to match the powers. So we don't have a sine x, and that means that we have sine theta to the power of 0, which is 1. That means that 2x minus 1 should be equal to 0. 2x equals to 1, therefore x equals to half. And 2y minus 1, which is the power of cosine x, should be equal to n over 2. n over 2. 2y equals n over 2 plus 1. 2y equals n over 2 plus 2 over 2. 2y equals n plus 2 over 2, and y is n plus 2 over 4. Okay, so now we've matched the powers. Now I'm going to write the beta function of half n plus 2 over 4 is equal to 2 times the integral from 0 to pi over 2 of sine theta to the power of all these numbers, which is eventually going to give me cosine theta to the n over 2 d theta. And what I'm going to do, I'm going to multiply both sides. First, I'm going to write as half b. I'm going to write it like this. And I'm going to multiply both sides by the infinite sum from 0 to infinity of 1 over n factorial. Infinite sum of 1 over n factorial. So you're going to see y times half beta of half n plus 2 over 4 equals to the infinite sum multiplied by the integral of cosine of theta n over 2 d theta. And notice that this term right here is exactly the integral that we were trying to solve here. So I can call this I, can call this I, and I is going to be equal to the infinite sum from 0 to infinity of 1 over n factorial times half b of beta of half n plus 2 over 4. I therefore is let me factor out this half here, beta of half n plus 2 over 4. Now beta function has a property that is defined as gamma of x, gamma of y over gamma of x plus y. Now I can use this property here to expand this beta function, and my I is going to be half the infinite sum from 0 to infinity of 1 over n factorial times gamma of half gamma of n plus 2 over 4 over gamma of n plus 2 over 4 plus half, which is 2 over 4, which is going to give me n plus 4 over 2, n plus 4 over 4. Now, gamma of half is root pi, thus I'm gonna write root pi here, and I can factor it out of the infinite sum, so it's root pi over 2. The infinite sum from 0 to infinity of 1 over n factorial gamma of n plus 2 over 4 over gamma of n plus 4 over 4. And that is the final form of our integral, which is an infinite sum of involving gamma functions. So the integral from 0 to pi over 2 of e to the root cosine x dx is root pi over 2, the infinite sum from n equals 0 to infinity of this monstrous thing right over here. And that is the final answer of our integral here. Hope you enjoyed this video. Please like and subscribe, and leave comments and tell me if you like the video or not, and I'll see you next video.